we need to start with understanding what directions are. Okay, so do you know what a compass would look like? Do you know on a compass where north, east, south, and west are? Okay, so in a compass, north is on the top, east, south, and west. Okay, so if I'm going to draw north 15 degrees west, I'm going to start north and I'm going to swivel 15 degrees to the west. Okay, that's what it's going to look like. Does that make sense? Okay, south 30 degrees east. So go to the south marker and then you're going to go 30 degrees to the east. Okay, does that make sense? So when you do these, they always start with north or south. They always start. Okay, so this one, is it closer to the north or to the south? So it's closer to the north. And they have swiveled 80 degrees in which direction? East. Okay, so they always start with the north or the south, and which way do you swivel, east or west? Okay, here's a problem. A kayak leaves an inlet and heads due east. Okay, so it's going to head due east, so that's straight across, for 5 kilometers. At the same time, a second kayak travels south 60 degrees east. So if I had a compass there, south 60 degrees east. Which means it's traveling like that. And it does it for 4 kilometers. How far apart are the kayaks? So that's what I want to know. How far apart are they? Okay, so here's what I think I'm going to start with. What is this angle in this zone right there? Do you know what, in a compass, do you know what a whole angle is in between the compass markings? From here to here, between east and south, what's that angle, the whole angle? Does it make sense that it'd be 90 degrees in that zone? So because this was exactly east, we can say that this is exactly 30 then. Okay, so we're done drawing. Now we have to decide which strategy we're going to go with. So what kind of info were we given? We have a side here, we have an angle, and we have a side. So that gives me a SAS. And if I have SAS, would I use cosine or sine law? So I'm going to go with the cosine law. Okay, so the formula would be, we'll go with x squared, 5 squared plus 4 squared minus 2, 5, 4 cos 30. Okay, so can you grab your calculator and figure this out? Don't forget, on this one is the one where you'll square root and answer. Okay, and check out, did we get the same answer here? 2.52 kilometers. Okay? A radar operator on a ship discovers a large sunken vessel lying parallel to the ocean surface 200 meters below the ship. Okay. So there's a ship on top of the water, and here's the ocean floor. And they discover that there's some kind of ship below here on the floor of the ocean. And it says it's 200 meters below. They want to understand the length of the vessel down here. They measure the angle of depression to the front and the back. Okay, so let's understand what the angle of depression is. Okay, so here's some words you might see: an angle of elevation and an angle of depression. So an angle of elevation is if you are flat upward. Okay, so think about your eye levels. If your eyes are looking straight out and you tilt your head up. An angle of depression is flat, angled downward. Okay, so flat, angled downward. Okay, so to the front and the back of the vessel here. So this would be considered the angle of depression because it would be from the flat, angled, swiveling downward. So that angle is 56, and the other to the back of the boat is 62. Okay, so how are we going to solve this? Okay, so can you figure out what that angle would be? Okay, because what does this make altogether? That would be 90 altogether. These two will make 90. Can you see it? So this angle would be 28. Okay, then can you get me the other angle? So that would be 90 altogether on that side. So this angle would be 34. Okay, so what I'm going to do is I want to know the whole length of the boat, but I'm going to treat these as two separate triangles, and then I'm thinking I'm going to figure this length out, and then I'm going to add them together. Okay, so two separate triangles here. So 200 and a 34. A 200 and a 28. That's kind of the two separate triangles I'm looking at. Okay, what else do I know here? I know that that angle would be a 90-degree angle. Okay, and then I can also get this angle because I have 180 in a triangle. So this is 56, and this is 62. Okay, what do you want to do here? We have all of our strategies that we know from the past now. Sine law, cosine law, or because it's a right triangle, if you like to do SOHCAHTOA stuff, you can, but there is a strategy that I think we're just going to go with because we're familiar with sine law. Does that make sense? So 200 over sine 56 equals something over sine 34. Okay, check if we're getting the same. I got a 134.9. Okay, now the other part, sine law, I'm going to go with those two pairs. So 200 over sine 62 equals something over sine 28. And this one I got 106.34. Okay, so how long is the whole vessel down there? So I'm going to add those numbers together because I separated them. So I need to put them together. So the final answer should be 241.24 meters. Okay, next question. We have a flight and it's going Altona to Dauphin and then to Melita. So do you know where all these towns are? They're all in Manitoba. So Altona would be somewhere over here. Dauphin is in Manitoba. Dauphin is over there. And Melita is over here. That's like a map. That's where the towns are in Manitoba. Okay, so the flight is in Altona. It flies to Dauphin. Its flight is north 44 degrees west. So north 44 degrees west for 305 kilometers. After stopping in Dauphin, it heads to Melita. When it heads out, the compass goes south 21 west. Okay, what if the pilot had to return to Altona? This is what we're going to figure out. What kind of flight path is it going to do from Melita to Altona? I guess I could mark the 215 there. Okay, now here's where we're going to bring last unit into play. Do you understand with compass bearings if this is 44, do you understand that we could do this because of the alternating interior rule? Because north-south and this is north-south, those lines should be parallel. Does that make sense to you? Parallel lines? So if this is 44, this angle in here will also be 44 because they're an alternating interior angle with each other. Okay, does that make sense? Parallel lines, alternate interior. Okay, now that whole angle is what? 65 degrees? Okay, so we can figure out this side length now. What do we have? What kind of situation? We have a side, an angle, and a side. So we're going to use cosine law. Okay, so x squared equals 215 squared plus 305 squared minus 2 times 215, 305 cos of 65 degrees. So there's the cosine law with the SAS. Okay, don't forget to square root your answer there. How are we looking? I got 289 and change. Yep, I saw some head shake. We're good. Okay, so Melita to Altona is 289.52 kilometers. Now we're going to have to get the compass bearing. Okay, so let's get this angle in here first. So I want this angle on this corner. So I'm going to go sine law. So I'm going to go 305 across from sine. I'm going to call it M for Melita. And then I can go with the 289 across from 65 degrees. So now I'm going to work with pairs. Okay, so times, divide, and this is an inverse, right? So 72.7, that was working. Okay, so that's the angle here. But that's not a compass bearing. So I'm going to draw a compass Okay, so now here's what I'm going to do. This 21 degrees, I need it. This 21 can alternate interior to that. I can flip-flop the 21. I can alternate it over the line because of the parallel line rule. So can you think about 21 degrees plus 72.7 degrees? Where exactly are you? 21 plus 72. That's 93.7 degrees. So you're actually lower than the east. Does that make sense? Because the 90 degrees would put you exactly east. Okay, so now we're going to make a compass bearing. So are we closer to the north or to the south marker? We'd be closer to the south marker. So now I need this number. How much did I swivel off of the south? And then that's in the what direction? The east direction. South swiveled how much east? So how would I get this number? Do you want to do 180 minus 93.7? So there's the compass bearing. South 86.3 degrees east. Okay, that's a little tricky. You have to think about where are you. So did you see that we are going to use these alternating interior rules quite a bit? Do you see the 44 flip over the line? The 21 can flip over that line. Okay, I don't want to do the last question today. I think I'm just going to leave it there.